Lesson 35. I can multiply a whole number and a fraction. For the first problem, you can see that it asks you to draw and label a tape diagram to show the following are true. So the first one that you see is 8/5 equals 4 times 2/5, which equals 4 times 2/5. Now that's very wordy, so we're going to break that down here. So you start with 8/5, which you see right here. So we just draw a tape diagram and we draw 8/5, okay? And then after that, you're going to break it down into groups of 2/5. So you can see here that I sectioned it off by 2/5. And then you can see we have 4 groups of 2/5. So that is proving that 8/5 equals 4 times 2/5. For the next problem, we have to prove that 10/6 equals 5 times 2/6, which equals 5 times 2/6. So I already have a tape diagram drawn with 10/6. Now, since it says groups of 2/6, I'm going to break it down that way. So you can see I'm just sectioning off groups of 2/6. And now I'm going to count how many groups I have. So 1, 2, 3, 4, 5. So that shows that it is true. For the next problems, we need to write the expression in unit form to solve. So the first problem that's given to us is 7 times 2/3. So I'm going to use the tape diagram to start. We're going to work backwards from the way that we worked last time. So we know that we need to have 7 groups of 2/3. So I already have marked out 7 groups down here. And we know that what we need in each group is 2/3. So I will mark each one off by thirds. Now you can see that when I marked off my 2/3 for each section, I end up with 14/3. So we can say that 7 times 2/3 equals 14/3. Now, if we write that up here, I want you to pause the video and try to make an observation about what you notice about this top section. Did you notice that 7, our whole number, times 2, our numerator, equals 14, and the denominator stayed the same? This is the process that we will use for multiplying a whole number and a fraction. The next problem is 4 times 2/4. So we know that we have to take our whole number times our numerator and that our denominator will stay the same. So we will have 4 times 2 over 4. So we know 4 times 2 is 8 and our denominator is 4. So we can say that 4 times 2/4 equals 8/4. Our next problem is 16 times 3/8. So if we take our numerator times our whole number over our original denominator, we would have 16 times 3 over 8. When we take 16 times 3, we get 48, and then our denominator stays the same. So we can say that 16 times 3/8 equals 48/8. Our next problem is 6 times 5/8. So we would rewrite it as 6 times 5 over 8, which would equal 30/8. So we can say that 6 times 5/8 equals 30/8. Our next problem is 7 times 4/9. So we would rewrite this as 7 times 4 over 9. 7 times 4 equals 28 over our original denominator of 9. So we know that 7 times 4/9 equals 28/9. 6 times 3/5. We are going to take 6 times 3 over 5. When we take 6 times 3, we get 18 over our original denominator of 5. So we get 18/5. 8 times 3/4. We would rewrite this as 8 times 3 over 4. We know that 8 times 3 is 24 over our original denominator of 4. Now, typically in these lessons, we haven't been allowed to leave our answers in improper fractions. Today, you are allowed to because it's the first time we're working with this. But typically, you would look at 24 and 4, and you would convert that to the whole number 6. Our next problem is 16 times 3 over 8. So we would convert that to 16 times 3 over 8. And don't try to do all of these by mental math. If you need to come over to the side and scratch out your multiplication, please do so. So I would do 3 times 6 equals 18, carry my 1. 3 times 1 equals 3, plus 1 is 4. So I know that it is 48. So 16 times 3/8 equals 48/8. Please pause the video and try E and F independently now. For E, you should have got 84/10, and for F, you should have got 162/100. Now we will apply what we just learned to solving a word problem. Maria needs 3/5 yard of fabric for each costume. How many yards of fabric does she need for 6 costumes? So if we know that 3/5 is how much she needs for 1, but she needs to make 6, then we know we need to take 3/5 times 6. So we would rewrite it as 3 times 6 over 5. 3 times 6 is 18 over our original denominator of 5. So we know that Maria needs 18/5 of fabric to make 6 costumes.